So right here I've got my homemade backup generator set up, all in this building here. And right here is where I have my commercial fire alarm system. And now that fire alarm system has two different detectors inside this building. In a recent video series, I installed this relay module in this building here. And I did some programming on the fire alarm system, where if either of these detectors are activated, it will activate this relay module and that will shut the generator down. Now when that happens, not only the generator will shut down and stop producing power, but our exhaust fan for cooling the generator will also shut down. And that definitely helps as far as reducing the oxygen and air that is supplied to a fire should that happen in this building, but that doesn't fully solve the problem with the building not being completely sealed. Now that's because when the generator's running or the temperature is high enough in this building, it opens up a damper to provide a source of air to be pulled by that fan through the building to cool the generator. Which that's the plan for what we're going to be solving in today's video, is making it so that when those two detectors activate and it shuts the generator down and it shuts the fan down, that we're also going to be shutting this damper here. That way, should a fire start in here, the building is completely sealed off. There is no source of outside air that can be easily pulled into the building. Fortunately, the majority of the equipment that is required to make this happen is already installed and is already here. We just need to make some slight modifications and configure things to do that job we're trying to do. To start here, we really need to take a look at what's currently here and how it operates. Well, what is in place to make this work, and how exactly is it making it work is what we need to discuss for this to make sense with what we're going to do. To begin with, one of the most important things that is here and what actually actuates the damper is, well, the damper actuator. That is this Belimo damper actuator here, which is powered over here with the damper control power. We'll talk more about how that works later on. Now, as far as making that damper do what we need to do when we need it, well, that's going to be the same thing that shuts the generator down, which will be our fire alarm relay here, which is tied onto the SLC loop and activates on those specific two detectors. These luckily have two sets of contacts, so we don't need to add any more relays or do anything, as they're already built into this module. So let's have a little talk about how this damper actuator works. It has a total of 3 wires going to it. It has constant power from this transformer right here. And then we also have this here, which is a power supply that is only off of the generator. Okay, I'm editing this video right now and wanted to say something. I know I mentioned it later on in the video, but I thought I'd say it right now. That is incorrect. That second power supply is running a strobe light, and I got confused because I used to have it set up that way, where it was a separate power supply ran directly off the generator that would power the damper's open signal when the generator is running. However, I'm using that same power supply that gives the damper its normal power, is also tapped off of there, running through a relay. That relay's coil is on the generator power, so that when the generator is running, it'll give that relay power, it will close, and then give the actuator its open signal. So everything, the way I'm explaining it, is the way it operates. It's just not a separate power supply. Okay, so this may get a little complex. For anyone that does controls or automation or works with this stuff commonly, you'll be able to understand this perfectly fine, what's going on. And if you don't, well, it may make more sense once we actually start looking at it and showing the wiring. But how that damper actuator works is 3 wires. Now, it's constantly getting 24 volts as operational voltage. If it only has that 24 volts, it will stay closed. However, on the 3rd wire, that is its open command, which is actually a variable command, where it's a 0 to 10 volt system, where let's say it gets 5 volts, halfway there, it will open to 50%. We're not using it in that way. We're using it either fully closed or fully open, where if it only has its 24 volt power, it will stay closed. And then if it gets a command on that 3rd wire which in our case is going to be the fully open command, as we're actually giving it more than 10 volts, but I've been told that they have a over voltage protection where they'll just drive it to the fully open position, and that's fine, which is what we're doing, is we're giving it in excess of that 10 volts, and it will drive fully open. Now it gets that fully open voltage or that command to open when the generator is running. That's why we have that secondary power supply. That transformer at the top is providing it constant power, which if that's all it has, it'll stay completely closed. However, when the generator's running, that relay will close and then be giving that third wire voltage from our same transformer that powers it. And then we'll be giving that third wire its command to fully open. Now, that's really all there is to it, and is what we're going to be doing in this video and with this setup to close it as soon as that triggers. We need to basically interrupt its open command, where should that fire alarm relay trip, it will interrupt that power going to the variable position leg of it, if that makes sense. It will shut because we're interrupting its power. It has no more command to open. But because it will still have its normal 24 volt power, that powers it in general, and if it only has that, it will close it. Now, if you only want a simple setup, that's what we have. In reality, there's actually a little bit more going on here, which won't really impact what we're doing as far as the theory of how it works, but in the actual installation, we need to be mindful of where we are tying in to our open command, as if we tie it into the wrong spot, our high temperature in there will still leave it open regardless. So this is what we're concerned with right here, which as we speak, it's actually closing the damper. This is the high temperature damper close. So this is a reverse acting thermostat, meaning as we get to the temperature that it's set to, once we hit that temperature, instead of a normal thermostat opening the contacts is for heating, this one's for cooling or ventilation, where the contacts will actually close once you hit the set temperature, which in this case, this thermostat isn't actually on the generator power, but we're still using it to drive the damper open. We're basically tapping in on one side of this thermostat to the damper's normal power, and once we hit that set temperature on here, it will close and it will give the actuator 24 volts on the command to open side, or our variable voltage side to open it. So we're kind of basically giving it a fake command, as we're just tapping into its normal power and giving it to that other leg to drive it open, because it will still have its 24 volts to operate, and we're just tapping off of that and giving it to its open command, which doesn't have an impact on it, as if the generators start, this will become energized and it will give voltage to this to open anyways. Of course, it won't make a difference if it's already open. There's basically no way it can fail, as if it's too hot, it will open, and if the generator starts, it will also open. The only way that this will remain closed is if the generator isn't running and our thermostat hasn't given it power on its open signal to open. But let's say it did, and the generator is either A, it's running, or B, which is really the concern here, because we're shutting the generator down anyways. So if we're shutting the generator down, it's not giving it power to open. However, if the thermostat is active, well, it's taking power off of our normal power supply. That's just giving it its operational voltage. And then, as I said, giving it to that open signal. So whether the generator's running or not, if it's tripped that high temperature, it will have the damper open. If we want to close it, we need to basically go in series with that thermostat and run it through our fire alarm relay. Therefore, even if our thermostat is closed, if the fire alarm relay trips, it will break that circuit. Therefore, it will lose its open signal and will only have its normal power, which will close it if it doesn't have anything else, which it can't, because we've just opened the other power source and the generator's already shut down. So that'll mean that the damper will close. Now, I'm fully aware that probably sounds quite confusing, which if you're not grasping it fully, I recommend watching my installation videos on it. That way you can actually see how it played out with getting installed, because more complexity has been added to it since then, and we would have started with the very basics and then worked our way up from there. But if I could figure it out as a 17-year-old, which I don't consider myself a very smart person, well, I'm sure anyone could figure it out if you really put your mind to it and sort of trace out how this is set up. So with all that said, and now that we've got a grasp on how this is wired and how we need to tie into this, well, let's do exactly that and get some wire. I'm just going to use some LVT because I'm going to run it in a way where it's pretty much protected. There's no way it's going to be hit by anything, and that's going to be a lot easier to work with as we're working in some pretty tight areas. So let's go ahead and run some wire from where our thermostat is to where our fire alarm relay is. Usually I would actually remove the generator from the building. However, this time, this is actually a pretty quick and easy job. We don't really need to take apart all that much, so I'm just gonna leave it in here and work around it. So if I do get in the way of the camera at all, I do apologize. It's just a fairly small building. So firstly, we're going to take off the cover on this thermostat. Should have said we're gonna take off the whole thermostat, actually. Okay, so we can see here a couple things. This wire is what actually goes to our damper actuator. So now we're going to open up our fire alarm module here. We can take this light bulb out to give us a little more room to work here. This cover is really tight in there. The module is cracked, so that's why we have a washer on this screw here. And something cool with this is if you actually short these together, you will be able to hear the shutdown relay in the generator. So if I take my keys here and connect those together, hear that? That's the shutdown relay in the generator. I'm going to knock out this knockout filler that's installed right here, as we're going to bring our LVT into there. And for the other side, I'm just going to come into that same connector that black cable's coming into on the left hand side where our power is coming from our power supply. I'm going to put a connector in right here, and then I can run my LVT into here. That should be good. So now that I've got that ran between either box, I'm going to strip this LVT here, which I can't remember if the ripcord in this particular one is actually useful or if it's just one of those crappy ones that breaks on you. That one actually works. Nice. Now I'll do this at both ends, obviously, but I can't really show you the other end because my fat ass is going to have to be in the way. Okay, so you can see that's ran in there, and that is ran behind there with that black cable, and then enters into this box here. So if I'm thinking right here, which that alone's hit or miss, I think I can just leave one side attached to this and take off the other side, and then splice that to one of these coming from our relay, and the other side can go directly onto there. Again, that's if I'm thinking right. So that right there is a risky thing. So let's just say we put our black onto here. It makes no difference. We'll put our black onto the terminal of this guy. I'm sure my arm is in the way. Oh, that just went in my ear, the other side of the wire. That did not feel very nice. Okay, so that's okay, so that's looped around there. And then this whole crimp here should be able to come off, and we'll just splice that to our white wire. Okay, so that's spliced on there, so that should be all good. Now, I'm not sure if I would have left it in the video or not, but I realized my explanation was wrong with this earlier. It was still accurate with how it works, where there's constant power and then the triggered open power, but the triggered open power isn't coming from this power supply down here. It used to be, but it's not anymore. It's now both coming from this, and this is just ran through the relay, so when the relay closes, when the generator is running, that sends its power to open. It's all the same principles, there just isn't two power supplies. So just for demonstration, I gave this power. So this is constant power, which is normally plugged into the generator here, and I plugged it in to replicate the generator running, which regardless of this being open, that will still open. However, that does not matter at all, because in real life, when this shuts down, the generator will stop producing power and close this, and I don't really want to have any way. It's less failure points with this, that there's a chance the generator could be running and this closes for some reason and the generator overheats. I would rather have less failure points, and it doesn't matter, because when this actually is triggered, that will shut the generator down, and then if it's shut down, that won't be open basically. So that end in there, that's all good, so I'm going to put that all back together now. Okay, so now we are ready to work on the other end. So we already know we want this to be normally closed, where it will regularly operate just fine until the fire alarm set off, and then it will remove that command to open power. So looking at this, we're going to be on our number one contact, because this relay up here, this is our number one relay. This is our number 2 relay. You see terminal 8 normally open, 2, T9 normally closed, number 2, and T10 is common, number 2. So we're going to be on number 1. And we already know we want to be on normally closed, so we'll be here for T6 and T7, which is common. We won't be using T5 over here, which is normally open. So this is pretty simple. We'll bring one wire into this guy here, T6, normally closed. Tighten that down. And then another one here will go into our T7, which is our common. And then that is all good for that. So with that done, we can install this back into its box here. Okay, now we need to do a test of all of this. So we're going to need to activate those detectors, and I don't want to set the fire alarm system off inside the house, so I'm going to disable our building B tie-in. So we just need to go to our main fire alarm panel in the house. And we will go to our disables here. Building B tie and disable. So there we go, we've got building B disabled. And we also don't need to be setting off our bells out here for no reason, so I will disable the bell circuits on this panel. Going to go into programming. I lied, we can't do this from number 1. We can disable detectors, but I guess we can't disable NACs. What are you doing over here? Ella? You could also just unplug them, but it's a little easier on things. You're not going to wear out your terminals if you do it through here. So now in level 2, under system setup, NACs, NAC 1, we will enable NAC 2, we will disable NAC 3. I'm not sure how many we're using. That one's not enabled, or that's NAC 2, sorry. NAC 3, NAC 4, I think it's NAC 3 we're not using. Okay, so we got all those disabled. Okay, so now out in the generator building here, I don't actually need the generator running because we've already tested that in another video. We made sure that the generator shut down when it was running, and I don't want to do that more times than I have to, so that's all good. We just need to make sure that the damper will close. But damper's already closed. So first we need to get the damper to open so that we can make sure that when the fire alarm goes off, that relay trips properly and we'll close it. So all we gotta do for that is turn up the temperature in here. Or turn down the temperature, I should say. Turn down the point that it's considered too hot. Right now is at like 23-ish Celsius. So we'll turn that down. And then that will get this damper opening. Slowly but surely. And then once that's open all the way, well, we don't even need it all the way, but once it's mostly open so we can obviously tell it's closing, then we can set off one of those detectors in there. Either one will set off that relay. Okay, I think that's good enough. So let's trip this detector, and I'm not even going to hold the camera looking at the detector. I'll hold it looking down here. Okay, so on the detector. Okay, so you heard that put the system into alarm. That's tripped our detector. That has activated our module. It's gone solid green. And our damper is now reversing closed. And if the generator was running, well, it would have shut down in the same process there, so it would no longer be calling for that damper to be open because the relay there has now dropped out. See, that's almost closed. And if I reset that, there you go. You heard that click once it finally started resetting. So the relay in the generator, shutdown relay would have let go, as well as this relay would have gone back, and now that started reopening the damper. So there, that passes our test. That did what it's supposed to. You can set that back to whereabouts it should be. Acknowledge, enter, programming, level 2, system setup, 2, go down, NACs 2, NAC 1, enabled, yes. NAC 2, enabled, yes. NAC 3, enabled, yes. NAC 4, enabled, yes. And now with that all good, that's all the testing we need to do. We can go back into the house and put that system back online. Alright there guys, well, with that being tested and that all working how it should, that's going to be it for this video. So if you did enjoy it, make sure to give it a thumbs up, and if you have any comments or questions, feel free to leave those down in the comment section. Also, if you do enjoy my channel, make sure to subscribe, and if you're interested, I do have an Instagram account at Pickle700 for bonus stuff posted earlier than you'd see it on the YouTube channel, that sort of thing. Alrighty guys, thanks for watching.